What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at exercise 38 of our Python exercise tutorial series. Without any further ado, let's get to it. So, one thing I should mention to you is that this specific exercise that we will see shortly, so it is kind of different compared to what we've been doing all along. The main idea and main topic, it's still testing us on loops, but the thing is, this one is going to specifically test our use and knowledge of what's called nested for loops. So if you've watched the Python tutorials that I've put up on my channel, I think I talk about nested for loops. But if not, then not to worry. Essentially, what nested for loops are and what it refers to is having a for loop within a for loop. So the most common, I would say, the most common way in which we actually create a nested for loop is using the iterator variables I and j. So you'll do like for I in range whatever, for j in range whatever, and we'll continue to populate it with code. So it's nothing that difficult. Essentially, first we will begin by reading the text prompt and then we'll take it from there. So, exercise 38. In this exercise, you will create a program that displays a multiplication table that shows the products of all combinations of integers from 1 times 1 up to and including 10 times 10. Your multiplication table should include a row of labels across the top of it containing the numbers 1 through 10. It should also include labels down the left side consisting of the numbers 1 through 10. The expected output from the program is shown below. And we see this is what they expect output to look like. Essentially, it's taking on a tabular form. We've got a header row 1 through 10 as well as a a row. We've got basically a header row on the top and a header row for the column on the side. So when completing this exercise, you will probably find it helpful to be able to print out a value without moving down to the next line. This can be accomplished by adding end as the last parameter to your print statement. For example, print A will display the letter A and then move down to the next line. The statement print A end equals string will display the letter A without moving down to the next line, causing the next print statement to display its result on the same line as the letter A. So that's fine, guys. Like, regarding that last portion, so having it explained to us there is not entirely the best, form of understanding. I will give you an example, right? So let's do A, B, C, D, E, F. Yeah, that's fine. So if we run this, you should definitely expect and know that we are going to see the letters A, B, C, D, E, F displaying on one line. That's just how the print statement works. And now if I do another print statement, right? Let's say G, H, I, J, K, L. We expect now, if I run this program, A, B, C, D, E, F is going to show on one line and G, H, I, J, K, L is going to show on the next line below it, right? This is because by default, right, by default, the print statement has a parameter called end is equals to, and it's basically having a, so end equals to is used to mess around with the settings of the print statement. This parameter here, it basically tells the print statement to place this character at the end of the string by default. And by default, the character is defaulted to \n, which as we know is a new line character. This is why A, B, C, D, E, F is printed on line 1 and the G, H, I, J, K, L is printed on the line below. It's because by default, the print statement defaults to the n equals \n. So, for example, if I go again now, let's just type some random letters and all of these display on separate lines. Again, because of that \n, which is being provided by the n equals to parameter. Now, if we want the print statement not to jump down to the next line, so essentially what we're saying is we don't want to have that this backslash n that is being appended to the string by default. We want to be on the same line. So in this case, all you do is just leave the n equals to parameter equal to a blank string. And now if we run this program, as you can see, it's causing the print statement not to jump to the next line. It's going to continue. Basically, each time you specify n is equals to blank string, it's going to keep the cursor of our print statement on the same line, as opposed to the having that backslash n, which causes it to move to the next line. So I do hope that makes sense. That short explanation makes sense to you. Now, using this logic of this n equals to blank string, we're going to code a simple multiplication table. So one thing I'd like to mention, for loops are very important in Python, right? Especially this concept of nested for loops. And in most cases, you're going to probably hear, I would say, criticism from other developers or, I don't know, just the people in general. And they may tell you that having nested for loops is kind of bad practice or, it demonstrates a lack of professionalism in Python. Well, to be honest with you, I do not agree with that. The concept and use of nested for loops in your script does not have to do anything with your level of professionalism of coding, right? Because truth is, as much as those people who say that nested for loops are bad practice, they need to also realize that it's because of the concept of endless or infinite looping that something like a GUI window is able to, constantly be running, right? So in reality, nested for loops, they are super concise, right? As much as at times, depending on the amount of processing that actually needs to be done, yes, resources can be an issue with looping, but that's the case for all loops. And bringing it down specifically to this concept of nested for loops, in which we have a for loop within a for loop, having nested for loops are really readable, especially to beginners or those who are new to Python. The concept of nested for loops enables them to actually understand the logic of a script as opposed to using, other complex structures, because as I always say, right, there's more than one way to do a problem. And for this problem as well, it's the same. There's not only the use of nested for loops that can actually give us this multiplication table. There's several more ways. But for this program and for our journey with Python exercises, in an endeavor to get that hands-on experience with Python, it's imperative that we understand the logic behind for loops and the possibilities, the use cases. So that's that. Now, first things first, I should mention to you that I personally speaking, I would regard or classify this specific problem as being challenging in inverted commas. Challenging, so I don't want to use the word difficult because nothing's too difficult when we apply ourselves to it. So that's why I'll use the word challenging. But it's nevertheless it's a super interesting program, and as you can see, I mean, can you imagine getting output like this? It's going to be very, very interesting. So let's see how exactly this is done. Now, first things first, we have numbers that we need to take into consideration, right? 1 through 10. They want this to be in the header on top and the index on the left side. So let's do this. So I'm going to proceed to set up constants, just two constants, min and max, so we know what values we are working with. And now I'm going to begin by having a first print statement. So this is all going to make sense in a moment, right? Essentially, what we really need to be careful about here is the formatting of our code, because we, at the end of the day, we want our code to resemble this very neat table. But it's good to understand that if you just if you print if you or if you attempt this program for the first time, you are obviously not going to get output like this straight away. You'll get the numbers, you may get the numbers correct, but with regards to the formatting, that may not work out in the first try. So This is where I am here to guide you along. So you see, looking at this, little snippet of output that they want or that they expect, you see this little space here. That space is what's being printed by the first print statement that we did. This little empty space here to give it that tabular look. Okay, so that's good. Now we set up a for loop for I in range min max plus 1. So you know the plus 1 is necessary in our case because we set max to be equal to 10. And you know, by default, the range function does not include the stop number. So if we just left it as max, instead of stopping at 10, the range function would go from 1 to 9. And that's why we just added 1 to it. Alternatively, you have the choice to set this to 11. Preference is yours. So let's move on. Now, print percent 4D. Now don't be intimidated by this, guys. That percent 4D, you know, right? Percentage D is the placeholder for an integer value in Python. It's the placeholder that's like supposed to be used in all cases of having integer placeholders. So the 4 we see behind it, in front of the D rather, that 4 is just literally telling us the number of places to, or in this case spaces is a better word, the number of spaces to have before actually placing the integer value. So I'll give you a simple example, right? Let's do print, and let's do maybe 50, right, just as an example. And then I'm doing print percent 1D. Let's provide formatting and 50. Now, I'm going to run these two lines of code, and I want you to see exactly the output it gives us. So I actually accidentally provided string when in fact that's the placeholder for integer. So focus now on the screen, and I want you to have a look at the output. To be printing the number 50, this is just going to represent a standalone 50, and then below that we're going to print percent 1D while passing 50. So have a look at this, right? It's the same. Now I'm doing percent 2D, percent 2D, that's fine. Now I'm doing percent 3D. Notice, guys, now the shift actually started coming about, because you know 50 only occupies two characters and therefore two spaces. And now with 3, we are essentially shifting that 50 value more to the right. Now if I do 4, you notice, I'm pretty sure, I'm 100% positive that you guys are understanding this 100%. So let's move on. Now that you know what the percent %d placeholder for integers does, we can proceed. We are providing, don't forget, we need to provide formatting to that percentage %4d. We are simply providing I. I is going to be taking on the value of the for loop while providing n equals to empty string. Let's run this. Notice, guys, we are successfully, we are slowly but surely building up on the structure of our multiplication table. We've successfully printed the header row, and notice we do have that very neatly formatted space in the header row, just like how the sample output was shown to us. Now moving on, let's do a print. I'm just printing a blank line. It's not necessary to have strings or inverted commas. You can just do a regular print. It's the same thing. Just force of habit, I always put a blank string. Anyway, next. So you know now, if I run this, it's basically having our print function that's jumped to the next line. Because in this print function, the default one is n is equals to \n. Next, let's set up another for loop for I in range min max plus 1, exactly the same as we've done above. Print again percent %4d. Let's provide formatting, guys. We are providing I, and we're specifying end is equals to and a blank string. This tells us that, you know what, in this for loop, this for loop is going to run and the print function is not moving to the next line. Now, within this for loop comes another for loop. Instead of I, let's use j. So in the event of having nested for loops, I told you earlier in the tutorial, the most common iterator variables that are used for temporary, the most common temporary variables that are used for nested for loops is for I in range, for j in range, and then your code. Now, let's do the exact same thing. Min, max, plus 1. I'll add a few spaces here to make it readable for you. Okay, that's good. Now, okay, for j in, exact same thing, guys. Print percent for d. Let's provide formatting. In this case, we are providing I times j, and we are specifying n is equals to blank string. And within the first for loop, we are printing a normal blank line. So guys, one thing I should mention to you, right? Let's talk logic now. This is all for the program. We've successfully completed the program. If you run this, you're going to see output as we have expected. Specifically, let's draw our attention to this portion here, the nested for loop. We've got a for loop running for I in range. You know, right? The header row has been already printed. So essentially, this nested for loop is giving us this block, not the first row. The first row is as a result of the first for loop that was encountered. The nested for loop is giving us this little rectangle of output. So let's talk about that. We've got a for I in range, min max, telling us that it's starting at 1. You know, min is the value of 1. So that accounts for this 1 being printed. Moving on, n is equals to blank string, telling us that, you know what, the print statement is not jumping to the next line. Okay, but now what's important to understand is that for each value in this loop is going to execute 10 times because of the range 1 to 10, including both numbers. So for each number in this loop, for each I in the first loop, j will run 10 times. And it's as we are seeing. For each I, j is running 10 times. Then we're printing a blank string with the default n is equals to backslash n, because print back defaults to a n equals backslash n, causing us to move to the next row. I is going to take on the next value, and as I told you, for each I, j will run 10 times because of the range. So I now has a value of 2. It's running 10 times. This for loop is saying that we are giving I multiplied by j, and this accounts for, you know, the index. This is basically our left column, the first number, and from here we are having 2, 4, 6, 8, 10, and so on. I will take on the next value, 3. J is going to run or execute 10 times, which accounts for this. And you know, each time j finishes execution or finishes running in that instance of the loop, we are indeed printing a new line, causing us to keep moving to the next line. And this accounts for the tabular format of output that you are seeing. And this is a super interesting program. We actually done with it. One thing that will be very fun to see is, let's play around with this range. You know, we can make this multiplication table as large as we like, and notice how powerful for loops or nested for loops can be in Python programming language. So guys, this video is clocking 20 minutes, and I do hope you found this super interesting. I found it interesting as well. With that, we will conclude the video here. Good luck with your work. Thank you for your time, guys, and I will see you in the next YouTube video.